Hello everyone, you are welcome back to another interesting question. We have here a cycle, this chord AB, which has its length to be x. This chord CD, its length is y, and this angle has its size to be A. It is the angle between this line BD and this line AC. What we are asked to do here is to prove this equation, x squared plus y squared equal to p sine squared A minus 2 pi xy cos A all over pi cos squared A plus pi cos squared A tan squared A. Provided here that area of cycle equal to 1 over 4p. So how can we solve this? It is very simple. We first label this point S. Now look at this triangle ABS. We can use the sine rule to relate this side AB and this side C. Let us assume its length to be Z. By sine rule, we know the length of a side divided by the sine ratio of the angle opposite to it is constant. That is, the length of this side BS divided by the sine ratio of this angle, say P, is equal to the length of this side AB divided by the sine ratio of this angle A. So Z over sine B equal to x over sine A. Multiply both sides by sine B. Here sine B cancels sine B, while here x over sine A all multiplied by sine B is x sine B over sine A. So Z equal to x sine B over sine A. Now look at this angle A and this angle here. They are formed by two straight lines intersecting. That is, they are vertically opposite angles. Vertically opposite angles we know are equal. So since this angle is A, this must also be A. Now look at this angle B and this angle. They both are subtended by this arc BC to the circumference. We know the angle subtended by an arc to any point in the circumference is the same. That is, this angle and this angle are equal. So since this is P, this must also be P. Look at this triangle CDS. We can also use the sine ratio to relate the length of this side CS. Let's assume its length to be T and this side CD. By sine rule, we know the length of this side CS, which is T, divided by the sine ratio of this angle must be equal to this y divided by the sine ratio of this angle A. So T over sine B equal to y over sine A. Multiply both sides by sine B. Here sine B cancels sine B, while here y over sine A all multiplied by sine B is y sine B over sine A. So T equal to y sine B over sine A. Now we know the formula for calculating the length of a chord in a cycle is 2r sine 1 over 2c. If we come here, draw a chord that connects this point and this point C. So we have a chord BC. Let's assume its length to be h. Based on this formula, this h will be equal to 2r sine 1 over 2c. C is the central angle. That is, the angle this chord BC subtend to the center. We don't have it, but if you look at this angle B, it is subtended by this chord BC to the circumference. From the cycle theory, we know the angle at the center is twice the angle at the circumference if subtended by the same arc. So since C is the angle at the center, it will be twice this angle B. So C equal to 2B. We substitute here. Now h equal to 2r sine 1 over 2 times 2b. 1 over 2 times 2b is b. So h equal to 2r sine b. We square both sides. So h squared equal to 2r sine b all squared. 2r sine b all squared is 2 squared times r squared times sine squared b. 2 squared is 4. 4 times r squared times sine squared b is 4r squared sine squared b. So h squared equal to 4r squared sine squared b. Divide both sides by 4 sine squared b. Here 4 cancels 4 and sine squared b cancels sine squared b. So h squared over 4 sine squared b equal to r squared. Retransposition. Now r squared equal to h squared over 4 sine squared b. The formula for calculating the area of a circle is pi r squared. So area of circle equal to pi r squared. Recall from here, area of circle equal to 1 over 4. Substitute here. Now 1 over 4 equal to pi r squared. Multiply both sides by 4. Here 1 over 4p times 4 is p, while here pi r squared times 4 is 4 pi r squared. So p equal to 4 pi r squared. Recall here r squared equal to h squared over 4 sine squared b. Replace this r squared with h squared over 4 sine squared b. So p equal to 4 pi times h squared over 4 sine squared b. This 4 cancels this 4. Pi times h squared over sine squared b is pi h squared over sine squared b. So p equal to pi h squared over sine squared b. This p is the same as p over 1. So p over 1 equal to pi h squared over sine squared b. Now 1 times pi h squared equal to p times sine squared b. 1 times pi h squared is pi h squared, and p times sine squared b is p sine squared b. So pi h squared equal to p sine squared b. Divide both sides by pi. Here pi cancels pi. So h squared equal to p sine squared b over pi. Keep it aside. Now look at this angle and this angle A. They are lying on the same straight line. We know the angle on a straight line is 180 degrees. So since this is A, this must be 180 degrees minus A. Now look at this triangle BCS. We can use the cosine rule. If we focus on this side BC, by cosine rule, the square of its length h must be equal to the sum of the squares of this z and this t minus 2 times the product of this z, this t, and the cosine of this angle facing side h. So h squared equal to z squared plus t squared minus 2zt cos 180 minus a. From trigonometry, we know cos 180 degrees minus theta is negative cos theta. Assume theta equal to a. Substitute here. So cos 180 degrees minus a equal to minus cos a. That is, this cos 180 degrees minus a is minus cos a. This minus multiplied by this minus is plus. So h squared equal to z squared plus t squared plus 2zt cos a. Let's transposition. Now z squared plus t squared plus 2zt cos a equal to h squared. Recall here, h squared equal to p sine squared b over pi. Replace this h squared with p sine squared b over pi. So z squared plus t squared plus 2zt cos a equal to p sine squared b over pi. Here we have z equal to x sine b over sine a, and here t equal to y sine b over sine a. Substitute here. Now x sine b over sine a all squared plus y sine b over sine a all squared plus 2 times x sine b over sine a times y sine b over sine a times cos a equal to p sine squared b over pi. Here x sine b over sine a all squared is x squared sine squared b over sine squared a. This y sine b over sine a all squared is y squared sine squared b over sine squared a. Here 2 times x sine b over sine a times y sine b over sine a times cos a is 2xy sine squared b cos a over sine squared a. So x squared sine squared b over sine squared a plus y squared sine squared b over sine squared a plus 2xy sine squared b cos a over sine squared a equal to p sine squared b over pi. From this side, we can see sine squared b over sine squared a is common. So we factor it out. Now x squared plus y squared plus 2xy cos a all multiplied by sine squared b over sine squared a equal to p sine squared b over pi. This sine squared b will cancel this sine squared b. So x squared plus y squared plus 2xy cos a times 1 over sine squared a equal to p over pi. Multiply both sides by tan squared a. Here sine squared a cancels sine squared a, while here p over pi times sine squared a is p sine squared a over pi. So x squared plus y squared plus 2xy cos a equal to p sine squared a over pi. Take this 2xy cos a to the right. So x squared plus y squared equal to p sine squared a over pi minus 2xy cos a. From p sine squared a over pi minus 2xy cos a, we can simplify into a single fraction, that is p sine squared a minus 2xy cos a times pi all over pi. 2xy cos a times pi is 2 pi xy cos a. So x squared plus y squared equal to p sine squared a minus 2 pi xy cos a all over pi. From trigonometry, we know tan theta equal to sine theta over cos theta. Let theta be a. Substitute here. Now tan a equal to sine a over cos a. Multiply both sides by cos a. Here cos a cancels cos a, while here tan a times cos a is cos a tan a. So cos a tan a equal to sine a. That is sine a equal to cos a tan a. We square both sides. So sine a all squared equal to cos a tan a all squared. Sine a all squared is sine squared a. And here cos a tan a all squared is cos squared a tan squared a. So sine squared a equal to cos squared a tan squared a. Now still from trigonometry, there is an identity that cos squared theta plus sine squared theta equal to 1. Let theta be a. So cos squared a plus sine squared a equal to 1. From here, sine squared a equal to cos squared a tan squared a. Replace this sine squared a with cos squared a tan squared a. So cos squared a plus cos squared a tan squared a equal to 1. Transposition. Now 1 equal to cos squared a plus cos squared a tan squared a. Multiply both sides by pi. Here 1 times pi is pi, while here cos squared a plus cos squared a tan squared a all multiplied by pi is pi cos squared a plus pi cos squared a tan squared a. So pi equal to pi cos squared a plus pi cos squared a tan squared a. Come here, replace this pi with pi cos squared a plus pi cos squared a tan squared a. So x squared plus y squared equal to p sine squared a minus 2 pi xy cos a all over pi cos squared a plus pi cos squared a tan squared a, which is this equation which you are asked to prove. We just prove it. Thank you for watching. Please subscribe, like, share and comment, and also turn on notifications. Thank you.